Welcome to video 3 for section 2 of our Solutions 1 unit. Today we're going to be talking about molarity, and this is something that you have seen on numerous occasions throughout the year and last year in Chem 1. So if you recall, when we talk about molarity, we're looking at the number of moles of solute per liter of solution. Now that's a little bit different than what we were talking about with percent by mass. So we're talking about liter of solution. That solution contains the solute. So our units for this are molar, or a capital M. And we can use molarity as a conversion factor just like we use percent by mass. So we know that molarity is moles of solute over liters of solution. So this can be a conversion factor that we use in our problems. So you are going to need a periodic table. Just to recall our rules when we use our periodic table and calculate a formula mass, please remember to round all formula masses to the hundredths place or 2 decimal place values. So if we look at our first example, it asks what is the molarity of a solution containing 3.65 grams of HCl in 2.50 liters of solution. So we're going to start with our grams, because we know if we're given grams 99 times out of 100 we are going to change it into moles. So 3.65 grams of HCl. So the first thing we have to do is get rid of the grams and change it into moles. So we need to calculate the formula mass of HCl. Hydrogen is 1.01, chlorine is 35.45, so it's 36.46 grams of HCl per mole. So the grams go in the bottom, 36.46 grams of HCl. 1 mole goes on top. So that gets rid of our grams. So we have our moles of solute. We know that we want the unit of moles over top of liters for molarity. So I'm going to use our conversion table, but I'm not going to put anything on top. I'm going to put what's remaining in our problem, the 2.50 liters of solution in the bottom. So when we do the math and look at the units, we end up with moles of HCl over liters of solution. Since HCl is the solute, that's going to give us the molarity. So we take 3.65 divided by 36.46, hit equals, divided by 2.50, and we should get our answer. Again, we're going to use significant figures. Both of our measurements in the problem have 3 significant figures, so our answer is going to have 3 significant figures. So we get 0.0400 as our number, but we have to make sure that we put the proper units and label. I am going to use the capital M for molar, but instead of just writing solution, I'm going to put HCl, because that tells me what this is. Molarity already has the liters of solution in it. So that is our answer. If we look at this, another problem, now we're going to go in the opposite direction. We're going to calculate a mass given a known molarity of solution and a known volume. So in this case, our substance is barium hydroxide. We need to have a formula for that. So that again relies on our Chem 1 skills. So barium is +2, hydroxide is a polyatomic and it's -1. So when you cross the charges, we get BaOH2. So in this case, molarity we use as a conversion factor. So we're going to start with our 3.45 liters. And if you want to write solution down, that's fine. You don't have to. You could just put liters of BaOH2. That works for me also. So we want to get rid of the liters of solution. Well, molarity is moles of solute per liters of solution. The barium hydroxide is our solute. So this tells me in 1 liter of solution we have 0.0600 moles of BaOH2. So you can see how we can use molarity as a conversion factor. This is this molarity. We just broke it down into its definition. That allows us to cross off our liters of solution. And now we have our answer in moles of BaOH2, but we want mass, so we end up with a mole to gram problem. So with formula mass, we know that it's always per 1 mole of the substance. So that gets rid of our unit of moles of barium hydroxide. And you can go ahead and pause, calculate your formula mass of barium hydroxide and your answer to the correct number of significant figures with correct units, and label, and then you can unpause the video and check your answer. For your formula mass, you should get 171.35 grams of barium hydroxide. That allows us to cross off our units of moles, and we're left with units of grams. Significant figures, we have 3 significant figures in our molarity, 3 significant figures in our volume. So our answer has 3 significant figures, and you should get 35.5 grams of barium hydroxide.